Hello everyone, it's Benny, and in this video we're going to talk about a practical implementation of normal mapping. And what I mean by that is, we're not just going to take the 3D API of your choice and show you, oh, this is something you can do that gets normal mapping. No. What we're going to do is we're going to take an actual 3D application, in this case a game engine, that doesn't have normal mapping, and we're going to show you how you can take that and add normal mapping to it, including some of the challenges that go along with it, such as how do I make it play nice with the rest of the system, and some of the tricks you can do to get it working efficiently for that application, such as how can I do normal mapping without completely destroying the performance of everything else in the engine. So, that's what we're going to do in this video. Let's get to it. Okay, so here we are inside an actual 3D game engine that doesn't have normal mapping. And we're going to show you how you can add normal mapping to this engine. Now, if you don't have a 3D game engine to follow along with, or if you just want to follow along with this one, or if you just want the textures and whatnot so you can use those in your engine, or whatever, what have you, then I'll be posting a link to sort of a starter file on GitHub that you can start following along from. And, additionally, I'm also going to be posting a link to a project that has all the code finished, so there'll sort of be a before and after going on there. And yeah, so both those links will be in the description, and just in case you have some issues building, I'm also going to be posting a video, not yet, but eventually, about how you can build, how you can troubleshoot the building process, in case you're having issues. So yeah, and again, the links to all that will be in the description. So yeah. And with that, let's go ahead and run, and if you're using this engine, you should see something like this, which isn't bad. That would work just fine for normal mapping, and really, you can start from here if you want. But I'm going to use the scene I used in my sort of example, just because, well, it's what I used in the example. So, right here in main.cpp, there's a place, right, this line right here, where I'm setting a texture to bricks.jpg. This is a texture for the floor. I'm going to change that to bricks2.jpg. So, now if I run, yeah, you see, got a little bit of a different brick texture going on there. And right here for test mesh 1 and 2, I'm going to change the mesh to monkey3.obj rather than plain3.obj. Now if I run, yeah, I should see the monkey face, just like I had in the example. So that's how you get the example scene if you really care. It's not particularly important, but just thought I'd show you how you do that. And now let's actually implement normal mapping. So, the first thing we're going to need are tangents in our vertices. Because if you remember, when I showed you sort of the theory behind normal mapping, we needed to calculate a rotation matrix so that we can rotate whatever normal we read from the normal map into the appropriate position. So, yeah. Under the engine, I'm going to go to, where is it? Under rendering, and vertex.h. And I'm going to change this to have another vector 3 for the tangent. And it's really that simple. Only other thing I'm going to do is I'm going to add, well, I'm going to sort of add a default constructor for that passes in a tangent, and I'm going to add another parameter to the constructor with a default tangent of nothing. This one's going to be called tangent. And yeah, nothing special there at all. But now that we've changed the vertex, we are going to need to change the mesh, because, at least in this engine, the mesh depends on the way the vertex is laid out. So, in init mesh, that's the only thing we're going to have to change. Or will we actually? Oh, yes we will. We're not going to need to change init mesh, but we will need to change the draw, because now we have another attribute for the vertex, and we're going to need to let OpenGL know about that. So, I'm going to copy and paste it. I'm going to have attrib pointer 3. Oh, which reminds me, I need to enable and disable that attrib array here. So enable array 3. So our third vertex parameter is going to be the tangent. And, let's see, it has 3 values, that's right. They're all floating points, that's also right. No need to transpose, they're the size of the vertex. Now the offset is going to need plus the size of, plus the size of vector 3, because, well, the tangent is a vector 3. It's a direction, just like the normal. And there. Now, we shouldn't have valid tangents, but at least at this point, we should be able to run without crashing. We should have something functional. We should have tangent data there, even if we're not using it. Let's see, actually, do we need to change shader? No, we don't. Never mind. So yeah, we just need to change mesh. We have all the tangent data, and that's great. But it would be nice if we had valid tangent data. So that also requires changing mesh, so don't know why I just closed it. But yeah. This mesh class is using async for tangent generation when it's like loading a file. So, well, I should say it's using async for file loading, so we can use async to generate tangents. And the way we do that is in async is very, very simple. This line here, where we're loading the scene, all we have to do, add a bitwise OR to all this AI process stuff, and that AI process generate tangent. So I'm pretty sure it's called gen tangents. I could be wrong about that. Okay. I guess I'm wrong. Oh, calc tangent space. Excuse me. So yes, I was wrong. Sorry, I got the name wrong. But yeah, and that will generate tangents. So of course, once we have the data in async, we'll just need to pass it into our vertex when we're actually, converting from async mesh to, well, this game engine mesh. So I'm going to have a pointer, call it p tangent, because that's what I've called everything else for some reason. Not sure why. I never use the p convention, but oh well. Or don't usually, anyways. So, well, this is going to be m tangents, because that's what everything is. Because everything in async is prefixed with an m. And there, that gets the tangent. And really just need to pass it in. There's nothing too complex here. This is just really moving the data around so it's in the right place in the engine. And yeah. If you're not using async and you don't know how to calculate tangents or something, you might want to look at the sort of math companion video where I talk about the process of tangent generation. So you can generate tangents if your model loader doesn't offer a function to generate tangents for some reason. So yeah. And that should give us valid tangents, so should be able to build and run, and yeah, it works. So good, that should be everything we need to do in the mesh itself. From this point on, all we should need to do is actually update the shader. Well, actually no, that's not true. But the biggest thing we have to do at this point is update the shader to actually use normal maps. So here I am inside the project folder. And the reason I'm here is because this is where we can find the shaders. So once you're in the project folder, go to 3D Engine CPP, go to Res, and then go to Shaders. And that should get you all the shaders in the program. Fortunately, we don't have to modify all of these. Since normal mapping is a lighting effect, we only care about the lighting shaders. And in fact, since we're not modifying the lighting calculation itself, we don't even need to modify the lighting.glh. We just need to modify these three. So let's go ahead and open them. And I'm going to start with lighting.vsh, the Vertex shader header thing. The Vertex shader thing. Now, first thing we're going to want to do is we're of course going to want to have an attribute for tangents. So I'm going to go ahead and create, if I can spell it, I'm going to create an attribute, vec3, for the tangent. So great, we're taking in the tangent that we passed into the shader, and now we can do stuff with it. So, our varying variables, mostly okay. We still need texture coordinates and world position for lighting and whatnot. The normal, however, we don't need anymore, because now we're reading the normal from a normal map. All we need here is the TBN matrix that's going to rotate the normal from the normal map into the appropriate orientation. So, I'm going to change that to TBN matrix. Uniforms are okay. So great, let's start modifying the code. I'm going to comment out the line with the normal 0. In fact, better yet, I'm going to change this to a declaration of a vec3 that I'm going to call n for normal, since the name normal is taken. And this is going to be our normal that after it's been transformed and rotated into the same orientation as the mesh. So there. And yeah, it's using the same calculation as the normal before, but we're just going to be using it for a different purpose other than passing it to the fragment shader. And same thing for tangent. We want to translate the tangent into the proper space, because, well, yeah, we're going to need that for calculating the TBN matrix and stuff, and such. So great, we got the normal, we got the tangent. There's only one more vector we need. It's going to be the bitangent. That's going to sort of be, I don't know if up is the right way to put this, but you know, yeah, it's going to be the direction that isn't the normal and the tangent. It's going to be the third axis in our rotation. And since we have the normal and the tangent, this is really easy to calculate. It's just the cross product of the tangent and normal. And be very careful, because this order is important. If you screw it up, you're going to get some rendering errors. So make sure it's cross tangent and then normal. And great, with that, we have everything we need to create the TBN matrix. So TBN matrix is going to be a mat3. Now, first row is the x row, that's the right, and the right vector is the tangent, so there. Second row, that's the that's y, so that's going to be the bitangent. And final row is the normal, well, it's going to be the normal. It's going to be the one we don't have left. So yeah, got a little flustered there, but yeah, that's how you initialize the TBN matrix. Nothing special, this is basic matrix math here, but this is how it applies to normal and tangents and such. So now the sort of tricks you can do. One thing you probably want to do is, with the normal and tangent vector, you'll probably want to normalize them. And the reason for this is, the model matrix here might have scaling, so, you know, it's just good, it's probably good just to normalize them, just to be 100% sure that you're not getting some really weird line errors, because it's not really expensive at all at this point in graphics hardware history, and it's just better to avoid the error. Unless you really know this normalized thing is going to make the difference in performance for some godforsaken reason, I just go ahead and normalize it. It's better to be safe and not screw things up later. And interestingly, once you do normalize it, you can actually do something that can improve the visual quality of, well, of normal mapping. And that is reorthogonalizing it. Because if you have an orthogonal TBN matrix, you're getting the best rotation quality. It's completely orthogonal. You don't have to worry about any odd effects like, well, I don't know, just odd effects from having a slightly non-orthogonal rotation matrix. So yeah, this is, it's nice. It's a trick to improve visual quality. And the way I'm going to implement that is by adjusting the tangent with the Gram-Schmidt process. If you don't know what that is, you can either look it up, or I'm going to talk about it in the math companion video for this. So, yeah. So tangent. Here's how you apply the Gram-Schmidt process. What you want to do is you want to start by taking the dot product between the tangent and the normal. This will give you the cosine between them. So cool, what can you do with that? Well, you can multiply it by the normal. And since the normal has been normalized, this guarantees that the normal is now going to be, well, sort of the length of the cosine between them. And that also means that it'll be at sort of the same plane or level as the tangent. So if I take the tangent and subtract the normal, that'll give me a line from the tangent and the normal. Since they're at sort of the same level, that'll also be an orthogonal vector. That's sort of the 30-second explanation of the Gram-Schmidt process. If you want more in-depth explanation of it, see the math video. I'll talk more about it there. And yeah, and you just want to normalize this because that's not guaranteed to be normal. And there you go. So that's it. That's really all the changes that need to be done in the Vertex shader. We've got our new tangent or TBN matrix. It's the tangent is reorthogonalized and whatnot. And yeah, it's nice. So let's work on the Fragment shader. The only really big thing here is we're going to want, well, there's two big things, but one of the big things is we're going to want to change the normal to the TBN matrix, because, you know, that's what we're taking in now. We're taking in a rotation matrix. Oh, and make sure you change the TBN matrix to a matrix 3, because, you know, that's important in both places. So yeah, there's the varying variables, TBN matrix and whatnot, and there. Final thing, for at least the VSH and FSH things, you're going to want a uniform sampler 2D for the actual normal app itself. And that's all there is to it. We've got a sampler for the normal map, we've got all the TBN proper. Now we can change the code that actually calculates the normal. So this is the main function of all the different fragment shaders for all the different lighting sources. And here's how you're going to want to do this. You're going to want to vec3, call it normal. And to start off with, I'm just going to set this to normalize normal 0. So this way, it's just everything as it was before, there. But of course, now we're going to want to take our TBN matrix and our normal map and actually read in the normal and adjust everything. Make it so that we're using the normal map normal and not the normal 0, which doesn't exist anymore. So here's how you'd go about this. Like I said, for the most part, this is letter for letter exactly like what you'd expect. You're going to take a texture 2D from the normal map and take the texture chords and read from it, and there. And that will get you the normal from the normal map. Now, this does return a vector 4, so you want to take .xyz, because, you know, only care about the vector portion of it, the xyz part. And there. The other thing here is that this returns a value between 0 and 1, which is great, except for the fact that normals are sort of like direction vectors. They can be positive or negative. So we're going to need to adjust this a bit so it's between -1 and +1. And that's pretty easy. Just multiply this times 2, so that'll change the range from 0 to 2. And subtract 1, which will change the range from 1 to -1. And there. So that gets me the properly oriented, that gets me the normal from the normal map. So all I have to do now is take the TBN matrix, multiply it by this, and that'll actually transform the normal. And there. Now the normal's read from the normal map, it's rotated into proper position, and that's all there is to it. All you want to do now is normalize it just to be sure everything's normal, and there you go. It's that simple. So now I've got normal map normals, they're being used in lighting, and all is good in the world. Now one trick you might want to do with this, since textures ultimately, since colors in integer format are sort of between 0 and 255, that's the range they have, one thing that's interesting is you can't actually represent up with this. Because, well, what would up be? It would have to be halfway between 255 and 0. 255 over 2 is 127.5, and that can't really be represented, so it's just rounded to 128. So what you might actually want to do is change this to 255 over 128 times this. That way, vectors that are at 128 end up being 0, and therefore you can have perfectly pure up vectors with this, without a little bit of x and y bias. And that can make the normals look a little bit better. That does bias the bumps a little bit, but that's usually less noticeable than biasing the up direction off to the side a little bit, so, you know. Either one. Which way do you want bias? Do you want bias in the bumps, which are usually bumpy and noisy by nature, or do you want bias in the up, which is a little bit more noticeable? It's up to you, really. But yeah, that's one trick you might want to employ. And that's it. That concludes everything we need to do with the shaders. So, updated all the lighting shaders, and there. So all we have to do now is change the material and the rendering engine so that, well, first off, that's probably more important. Let's change the rendering engine so that, you know, it actually supports all the normal mapping stuff we added to the shader. And really, this is pretty easy. All we have to do is let the rendering engine set at space, set some texture unit for the normal map. So just copy the sampler map.insert, change it to normal map, because that's what we have. And I'm going to say it's in slot 1. So there, whenever we have normal map, it's going to be stored in slot 1, and there you go. That's all we need to change with the rendering engine. Final thing we might want to change is in material. Well, we're going to want to change, and I'm going to go ahead and put this in a new line. and we're going to want a texture pointer that I'm going to call normal map, because, you know, we want to take in a texture for the normal map. And that's going to be done at the bottom. We're going to add a new texture called normal map, because, you know, that's what we call it in the shader, and I'm just going to call this normal map, and boom, there we go, we passed it in, and there. Now, one thing you probably want to do here is you probably want to have some default texture for normal maps. That way, if you want something that doesn't have normal maps, it'll still be rendered validly with the normal map code, just it won't look like it has a normal map, because the only direction it'll have is up. So under textures, I have a texture just for that. It's called default normal.jpg. So, the normal map right here, it's going to be a new texture. I know what you're thinking, but just bear with me for a moment. And it's going to be called default normal.jpg. Now, I know what you're thinking. What are you doing? You're allocating memory in a default constructor that's just asking for memory problems. And you're right, usually this would be a problem. The reason it's okay in this particular case is because the whole engine is set up to delete all the textures in a material in the destructor. See right here, it's deleting all the textures in the destructor. So in this case, it's okay to allocate a texture here, as long as that texture is being added, because it's going to be deleted anyways. So usually this isn't okay. If you're going to do something like this, though, be very, very sure it's going to be deleted. That's all I'm going to say about that. But yeah. And honestly, that's just about all we need. So first off, I'm just going to build, just to make sure we haven't broken anything. Shouldn't have, but just to be sure. And let's run. So, okay. This is a good indication that something's not quite right, because we shouldn't have had lighting be basically inverted like that. So, in other words, I've done goofed, I've screwed something up, so let's see what I've done. Let me see what I've done wrong. And it's no huge deal. Right here, I accidentally used integer division, not floating point division, so this is giving me some really wonky value. So, yeah, change that to something like 255.0 over 128.0, and everything's going to work a lot nicer. Now if I run, don't need to rebuild because it's a shader, yeah, looks a lot nicer, no bizarre errors. Of course, we're still not using an actual normal map, so let's go ahead and do that. I have normal maps for both the bricks and bricks normal, so let's pass in those normal maps. So for bricks2.jpg, actually, yeah, I can start with that one, doesn't matter. I'm going to pass in new texture. I'm going to do it on a new line because this line's getting a little bit long. So, yep. Just going to space over to over here. And for the texture, I'm going to say bricks2 normal.jpg. So there, that should give me a texture for... Oh, make sure you actually close the brace. And yeah, look at that. We've got a normal map. We've got proper normal maps going on. Yeah, it's working just fine. Let's go ahead and add that for our bricks as well. So, I'm just going to copy and paste the space, because, yeah, I don't want to space that out again. Yeah, but can you blame me? So yeah, in fact, I'm going to copy this as well. So, there. I'm just going to change it to bricks normal, because, well, that's all it takes. And there. For both of them. Build, and I forgot a comma here. And now if I build and run, yeah, got normal maps, nice smooth bumps on, or guess bumps aren't really smooth, but got some nice bumps on the monkey face, and I've got this nice normal map on the floor. Now you might have noticed the floor looks a little bit strange. It looks like, lighting's going in the wrong direction. What's up with that? And this is just a little thing you might encounter. I've done this on purpose, don't worry. Don't worry, you haven't screwed something up if you've seen this. I did it deliberately, but yeah. This is an issue you might run into with normal maps, because there is sort of a discrepancy with textures. Some textures have the Y facing one way, and some normal map textures have Y facing the other way. So sometimes you see the lighting facing the wrong direction. So what's going on there? Well, just that. I already explained that. And there's a few ways you can fix that. If all your textures have Y going the wrong way, one thing you can do, well, first off, one thing you might be tempted to do is go into your shaders, and in Vertex shader, you might be tempted to just flip around the cross product, so it's normal, comma, tangent. And if you run that, you see it does fix the normal map. It is going in the right direction now. Of course, it breaks this one because that one's actually facing the other direction, but you know. But you do not want to do that. And because any other operation that relies on tangent space, like parallax mapping or something, it's going to break that. So that can fix it if you're absolutely 100% sure normal mapping is the only thing you want to do involving tangent space, but you probably don't want to. Another thing that can fix this is in mesh, because right now you see I'm flipping the UVs. If you don't flip the UVs, or if you're not flipping them, flip them, you know. If you flip whether you're flipping the UVs or not, I guess, as you see, that can also fix them. It's still going to have the issue with this, but as you see, it is fixing the issue with, well, you know, these. And in fact, no, never mind. I thought I saw something that I didn't, but yeah. And again, if all of your normal maps are have sort of the same wrong normals, if that makes any sense, then yeah, that can fix the issue. But if you have a case like this, where one of the normal maps, in this case the sort of brick bumps, is working correctly, and the sort of floor bricks are the wrong direction, what you're probably going to want to do is you're probably just going to want to change the texture. So you're probably just going to take brick2 normal.jpg, yeah, this texture, and just invert it on Y. Just take, for every pixel in here, invert the Y. So it's very basic code if you don't have an image processor to do it for you. Just go through and for the green component, do 255 minus the pixel, and there you go. Yeah. So that's something you might want to do. So I did that just to bring that up and show you. But yeah, other than that, that's all you need to do to get normal mapping working. Just wanted to bring up that issue because you might run into it. Some normal maps do it one way, some normal maps do it the other way. And it can get a little bit interesting, to say the least. So yeah. And actually you can see it in the normal map. See, in these bricks right here, the sort of edge toward the light is green, and in this one, the quote-unquote proper one, the edge towards the light is sort of, well, the edge away from the light is green. So yeah. I don't know why I spent so much time on that, but yeah, I wanted to bring that up because that can cause some weird effects. And yeah, so I hope you enjoyed, hope you learned, and if you want to do more or know more about some of the mathematics behind normal mapping, like calculating tangents and the Gram-Schmidt process for reorthogonalizing the matrix and whatnot, then you can look at the companion video. Well, I don't know if it's called companion video, but you can look at another video I'm going to put up for a little bit of the math that's relevant to normal mapping, and I'll show you how some of that works. So thank you, hope you enjoyed, hope you learned,